today I'll be considering a question that one of my students brought to my table, and one of my registered students brought to my table, and although he had solved it, so he needed me to throw more light on this, so I decided to make a video so that everyone can benefit from it, since we're discussing on functions. And if probably you don't have more understanding of what I'll be solving very soon, less than a second, just quickly go back to our YouTube videos, the recent ones, or go to the playlist Functions Made Easy. You will see everything I've talked about, everything I've discussed about functions, and this will not be a problem. So I just decided to just throw the video up for everyone to learn. So these are UNICAL Math Assessment question for 100 level students that is being given to weigh their understanding in mathematics, and it's just among what I'm taking my students on. So the question says, if f of x is equal to x plus 1 and g of x is equal to exponential x plus 1, find an expression for g of f of x and show that it is continuous at x equal to 0. I think this is the part that's to shake a little bit when inside the equation says to be continuous, and so on and so forth. So let us solve it. So solution, we have that f of x is equal to x plus 1 and g of x is equal to exponential x plus 1. So g of f of x will be equal to exponential. When you have this, you put the whole of this. So we have x plus 1 plus 1. So this will give us exponential x plus 2. All right, this is the first step. Now the question will say that and show. So this is the first one. We've solved for g of f of x, and this is what we have. I said it earlier that if maybe you're getting a little bit like it's not really into, you should go to our YouTube, just check the previous videos we've uploaded on functions. You'll see them. And the most important one on function is what happens when you put a function into another function. This was explained, everything was there. It's just there, sorry. So go check it out. So let us solve this. Now the solution says that and show that it is continuous at x equal to 0. There are three conditions that must be met for an equation to be continuous. Three conditions. So I'm going to be stating them out. One of it is that one condition for an equation or for a function g of f of x must be defined. And how is that? Okay, so from here we have that x is equal to 0. So g of f of x will now be equal to exponential. Where you have x, you put 0, 0 plus 2, which is equal to exponential 2. So g of f of x is defined at s equal to 0. Is defined. And the second condition for an equation or for a function to be continuous is that exists. So the limit as x tends to 0 of g of f of x will be equal to what? So where we have this, we put e of 0 plus 2. So the limit as x tends to 0 of g of f of x is equal to exponential 2. It is ticked up. So the last condition that must be met for a function to be continuous is that the limit as x tends to 0 of g of f of x must be equal to g of f of 0. That means what's equal to this. Now we can now see that this is equal to this. So we can say that g of f of x is continuous at x equal to 0. If you find this video once again very educative and informative, please do it to subscribe, like, and share to others.